Hello guys, this is Siri from Siri Tutor Blogs. So today we are going to look into some more Lambda expression examples. So because the reason why I'm making this list of Lambda videos is because it's very important during the interview time when you're going for a Java developer or Java junior or mid-level anything. People are going to ask you if you are aware of Lambda expressions, Java 8 new enhancements or not. And most of the companies have the code being written in a Java 8 enhancement way. As a Java developer in Amazon, I know I have seen people writing Lambda expressions and Java 8 new enhancements. So in order to for you to understand the code, learn the code, in order to do some enhancements or do your task which is given to you, it's very important to have this knowledge. That's why from the interview point of view, all my videos are uploaded here. If you go into Google and if you type Siri Tutor Blogs and click OK, the first link which is here, Siri Tutor Blogs, you can go into here and click on this playlist and go to Java Lambda. Okay, so you can refer my videos. They have lots of Java examples related to Java Lambda, functional, about functional and functional interfaces. All the different examples are there. It's given. Please go just check up those videos. And coming to today's session, we left last session until predicates. So predicates, and we have even covered static methods in interfaces and how to call classes from an interface and how to run from interface instead of running from a regular class. We have seen that in the last class. Today we are going to see predicates, functions, consumers, suppliers. So let's see how many we can cover. Let's dive into it. So last time we have seen a predicate. Just to give a little bit of content of predicate is a conditional check that takes one input value and returns a boolean, right? So the way we declare a predicate is something like this. So we saw this with I think we even implemented in an object. Right now I'm just declaring it in with a primitive type. So here is the primitive type, integer value, data type. I'm taking primitive with a integer and I1 p1. So I equals to I with a lambda expression I. So just wanted to see if this value is even or not. Before that we have to import predicate package and then just sys out. Okay, v1 dot for predicate, I think it's apply, or what is the function for predicate? It is test. It's always test, right? And then we have to give the value 10. 10 is an even number, right? So we are supposed to get true, and let's give 25. For the next output we have to get false. True and false, both are false. Let's do one thing. Let's do I think why both of the things are false? I don't understand. So did we? It's an integer type. Did we save it, by the way? Yes, we did save it. Yeah, we have to for checking the reminders. We have to use modular sign instead of a divided sign. So modular sign will give a reminder 0. So now I think it should give expected answer. Yeah, so this is how the predicate we have seen in the last session. Now we are going to see predicate being used in a employee class. Okay, let's use it in a object. We have seen just in the primitive data types. Let's see it in the objects. Let's declare class variable class here, and then let's declare some variables here, just simple variables, not very complicated, just to make sure we get the concept correct. Okay, so public employee, I'm just declaring a constructor now, string name and int sal. This dot id equals to id. This dot name equals to name. I should have used my inbuilt constructor invocation. That would save me some time. But that's okay. Okay, the constructor is done. Now the constructor is done. Now what are we supposed to do? We'll just add a toString method so that it will be easy for us to read the values. If not, it will give its own format of class name. So return id plus what is it? Name plus and then salary. Okay, salary. All right. Okay, yeah. So now I'm going to create a predicate of employee type, and it accepts an employee type attribute parameter, and it will give a string as an output, right? So here we are going to give a e value with a lambda expression, and then the output of this is just a println statement. Hello Siri. Okay, let's do that. Let's create a employee object here. Oh, we have already declared a parameterized constructor, so we have to give some values here. That's okay, we'll give it id, right? The first one is id is 101, Siri, and then salary is 10,000. Okay, all right. Here also we have to give those I don't think so. We don't need to give the values here. But did we import the predicate? Did we? Yeah, we did already, right? All right then. Then just we'll sys out. Okay, it is complaining because we gave some extra character here, and then okay, yeah. System dot sys out. Okay, and then we are going to give this employee type, and then e, and then the oh, no. What how we are supposed to call this predicate is p1 dot test, right? p1 dot test of e comma e, right? And that's pretty much it. So what is it complaining about? Why is it complaining? We are giving employee type. Incorrect number of argument type. Oh, okay. Why? Oh, okay. So if we are taking a predicate, it should have only one input value, and the predicate can be what it is saying. Represents a predicate boolean value functionality of one argument. Only it accepts only one argument, so you cannot give more than one argument, but it returns a boolean. Predicate always returns a boolean. So let's do one thing. Make sure it's greater than 2. Okay, it returns true. Yeah, and it returns true, and that should be it. Semicolon is missing here. And what's wrong with this one? Oh, E is already here, so let's not give E here. Yeah, it should be pretty much it. Yeah, true. Why is it complaining? Why? Is already defined. Oh my god. Let's refactor that. Rename. So guys, see the way we have to refactor. Renaming is pretty easy. Okay, let's uncheck the rest. Update the differences. Why it's not? Come on. Update. Okay. Didn't I check it like this? Refactor. Rename. Oh, okay, I have to rename it, right? So rename from employee to employee 1. Let's say employee A. Let's do it employee A, because I don't know how many employees I have already generated. Update variables and methods. Okay, all the variables and methods it will update. Okay, finish. Thank you. It has updated all the variables. Oh, it didn't update this one, no? But okay, that's okay. I think we have to check all the check boxes there. Then it will do that magic. E. A. Okay. So yeah, this is pretty much it about the predicator, how we can use. So just guys, you can follow all these things over here. You just have to read how it is being how are they defined. You have to make sure you read the libraries properly. If you go here, java dot I usually go here for checking their signatures to make sure they are properly defined, to make sure that I am properly defined. So it will give you all the information. See, for example, this bifunctional interface. This it accepts two variables. It can be any type. It can be any object type, two integers, object under integer, and it returns a return type. That is what it represents, the functions that accept two arguments and produces a result. This is two RT specialization of functions. Okay. All right. You can come here to read the documentation, and you can just go from there. Okay, this is pretty much it about predicate. Let's look into what is the next function we have. Predicate, and then you have functional interface. I already covered about functional interface. If you remember, it is already in our previous videos. So you generate an interface, and you give an method, abstract method in an interface, and you try to implement the same method using an interface lambda expression. I think you remember that. If not, let's quickly code it so that you guys can remember. So we have an interface here. Interface. No, interface. Yeah, interface has to be capitalized, right? Or I don't think so. It should is lowercase. Okay. Interface int one. So public void sum. There's an interface like this, and we are going to look how we can implement. I'm just showing you in the previous video of what I have done, but I'm going to show you with objects how we can implement it with objects, because real time, guys, in the real time in the companies we always use objects. We never use data types or primitive types like this. We never use primitive types. We might use it, but it's rare. But most of the times when we read data from one platform to another platform, it is always in the form of objects, Java objects. So let me show you. We cannot do a high jump to objects, but we have to go always from the low to we have to get into the ladder step by step. So that's why I'm showing this. So here is an abstract class, and what are we supposed to do is in here, how are we supposed to declare a function, a functional interface, right? Just type function, and then function, and then we are taking two input variables, right? So it's an integer variables, and it's two integer variables. Okay. So when it is taking two integer variables, we have to declare always as a bifunctional, right? Let's include this bifunctional. Okay, bifunctional, and then by equals to, then you enter the variable inputs here, and then the lambda expression, what are they going to do, what is the functionality that they want to know. No, it should not be a plus b, it should be a comma b, and what are these two inputs are going to do is a plus b. Okay, that's it. So here, why is it giving an error? They should not be a type. The target type of this expression must be a functional interface. Yeah, right. Okay, I got it. So you have to declare the function name, guys, here. Function name bi, okay, and then the method name doesn't matter. You don't have to specify the method name, it is sum, right? But since this is only one method, it will become an abstract method, so you don't have to specify what it is saying. Public void, void method cannot return value. So okay, this is okay, we have given void, right? Let's give integer int return type, then it will not complain. Okay, because here we are getting some value out of this operations, so that's why it is complaining. sys out, and then bi dot sum of 10 comma 20. But yeah, 10 comma 20 we are returning yeah, 10 comma 20. So let's run this. Yeah, we got it. So yeah, using bifunctional, how we can call an object on an object method using an interface we have seen. Now let's jump into concepts like we have finished predicate, right? Now let's see functional. Let's combine three things in one example: the predicate, function, and a consumer. Let me just give you a brief explanation about predicate. Predicate you already know. It's a conditional check and it returns only boolean. And functional function is function in lambdas are like it takes one input value, and it can be any input, it can be any object, a primitive type or a string or anything, any object it takes, and it returns any type of object, any type. And a consumer is it consumes the input, but it doesn't return any output, it returns just void. So let's look into that kind of example, and let's see how we can work with it. Okay. um, let's open a new project, not project, file, right? We need a new class. Let's open a new class here. Let's open a class name. We can call the name of the class as test. Test is already there. Okay. Lambda examples. Okay. All right. And let's create a main class method here. Here let's here let's create an student object here. We'll create a student object. Let's create a class with a student and let's define some properties for the student. Not very complicated, but just name and the marks. Those are the main important things for the students, right? Name and the marks. And let's define a constructor. Let's define a constructor very quickly. Yeah, these are the fields. Okay. Yeah. And then let's then yeah, I think that should be pretty much it with the student. We can define rest later. Yeah. Now let's define a function. We'll define a function directly in the main. Okay. So function, it's like a function which accepts. See, I'm directly telling you the function example directly with an objects. I think we have seen this function example in the previous video with the primitive types. You can refer those if you want to do it in primitives for your hands-on experience. But now I'm showing it with student. Okay. So this function is taking student as an input and then it returns string. Okay. It is returning a string. Now I'm declaring a function and I'm gonna give s is my student input, and this is the lambda expression, and what it is gonna do is let's declare this function variable. Okay. So yeah, so what it's gonna do is it's gonna read marks. Based on the marks, we are going to define their grades. Okay, so int marks equals to s dot marks. Okay, all right, and we'll take grade as a string type, and then we'll define the grades now based on the marks. So if the marks is greater than 80, what I'm going to say is grade equals to A grade, A grade. Else if marks, okay, why I don't want to call, I don't want to type it. If marks is greater than 60, it's B grade. Okay, and else if marks is greater than 50, it is C grade. C grade. If marks, okay, else if marks is greater than 35, it is D grade. Okay, else else grade equals to failed. Okay, so I have defined I have implemented grade how it has to be defined. Now I'm just gonna, because it is returning a string data type, I will return grade. That is pretty much it. Okay, it's not showing any errors, right? And now I'm going to create a predicate. So function is just, it's gonna take an input value, it does some operations, it does some manipulations or anything, it can be anything, business logic, it does some processing with that input and gives an output as some string type or an object type, it can be anything. Okay, now let's define a predicate. This is also of student type, and whatever we going to do is we are going to take a student object, and with the marks we are going to find out if he is 60. Okay, we are doing a check, conditional check here. Let me import the package. I'm going to just check, I'm just checking the conditional check. Okay, what it is saying, S cannot be resolved. Why? Let's use S1. Okay, we, because it's is it saying is a duplicate S1 cannot be resolved? Why is it saying like that? Oh, okay, I have, what I have to do is I have to create an object and then use that object, right? I have to first of all take that object and then use that object. That is what it is saying, it cannot resolve. Okay, then now I'm going to create a consumer here. The role of the consumer is just to take the input, consume the data, do some processing on the data. Maybe it can be updates on the data, and then it doesn't give any output. So the output is always void for consumer. So I'm going to create a student consumer C, and then what it does is on the S, on the student object, what it is doing is it is just the meaningful way of not giving any output is just to print something out of this, right? Sys out will just print. Oh, here it won't work. Okay, system.out.println of we will say student name is student name is s dot name, right? S dot name. Let's import the statement here. Come on, come on. Why consumer, right? Yeah, you have to come. Student. Yeah, this is student. All right. Let's print the gray marks as well. Let's print the marks, and then I want to print uh, the function. Okay, let's print the function, because based on the marks we have already written a function, right? So what it does is it will take the student and then it will see which from the list of all the students, which student got the highest grade. Okay. um yeah, all right then. Next, what are we going to do? Let's generate some student variables here, and let's populate it with some student values. Okay, let's create some student array here. S equals to, okay, new student of Siri, and marks is 100. Okay, well, let's copy paste some values. Mm. Enough. Siri Giri is 60. Let's say 65. Okay, let's not say 65 because distinction is A grade is above 60, right? Meera 45 and John is 25. Okay, 25. All right. We have declared all the first. Let's print the S. Let's print and see if we are getting all the inputs, all the desired outputs, like whatever we have entered, are we seeing all those values or not? So S is where it contains all those variables, right? And we have to create the variables like this to um, iterate through all the values. I think there is a semicolon necessary here. Why is it complaining? And I think there is one more bracket missing. Did we give? We gave semicolon already. Okay. Now let's sys out s. Let's print all the values. S1 dot name, and let's give a space. S1 dot marks. Okay. All right. Then even we have created a predicate, right? Let's define a predicate also here, so that uh, it can implement that, it can include that conditional check as well. So p dot, so the predicate name, what did we gave for the predicate? It's p, right? P dot, what is the method? It is test test of s1, correct? Test of s1. If there is we are asking to do the conditional check on this list, and if the list based on the list it will display. So the conditional check what we have put here is, if it is greater than 60, we are supposed to see a grade, student. Okay, a grade student. That is the conditional check we have put. Now let's even implement. We did not utilize this consumer yet. So let's use the consumer also. Before using consumer, let's run the program and see. Yeah, so this is where, yeah, we got our city is what the thing we have got based on the predicate. We have a conditional check, right? Only city will going to display, because city is where what that will satisfy this condition greater than 60. So yeah, now let's even write a consumer. Let's see how the consumer works as well. C dot accept of S1. Here what it does is, the consumer, what it is doing is, it is it is like it is taking the employees, it is iterating all the employees one by one, and it is taking one employee, displaying it, and apply S. It is also defining the grades, right? It's also defining the grades. F dot apply. So it is doing this one as well. Let's see. Okay, see, I think here city grade A, student name. Oh, yeah, we did this student name. We just copy pasted, right? This should be marks, and this should be marks. And let's put a println statement after this, so that we'll have we can view the results properly. Okay. Yeah. So this one is from the predicate, the output, and this one is from this consumer. Okay. All right. We can even put the consumer here. We can just put the consumer here and get rid of this iterator altogether. Yeah. All right. This is pretty much it about all the three: the predicator, the predicate, functional class that we have implemented here, the functional interface, the predicate, functional interface, and the consumer. Okay, and the consumer. So yeah, so I hope you understand this concepts properly. And you can always go into this library to refer what exactly it is taking as an input and what is the output. Based on that, you can change your code. Okay, then let's see consumer chaining of consumer, how to implement chaining of the consumer. So let's take another example here. Let's say we'll take Lambda EX2. Okay, and then now let's take a class, and I'm going to explain about the consumer chain now. So here we are declaring a class called reviewer, or maybe demo. Okay, some class which gives which gives some kind of reviews about some reviews or opinions about of something, some kind of information. Maybe we have some notifications release every time, or maybe if there is any show, it gives a review about the show. Maybe you can think like that. So here we are going to just define a property. Okay, just name property, that's it, not more than that. And then let's create a constructor, and and this dot name equals to this dot name, right? This dot name equals to name. Yeah. Okay, and that's it. That's pretty much it. So here we can the role of a consumer is just to take the input value, and it doesn't return anything. It just process it, and then it doesn't return anything. That is the main intent of the consumer, right? So we are going to create a consumer object of a demo here, C1, where what it does is it will take the demo object, and then it will sys out. Okay, maybe it will sys out, it'll print out some value where m dot name, just m dot name plus, it will give a review. Okay, the name of this, the name, whatever the things which is published, it will say it's ready to release, something like that. Okay, and let's import that, and we'll take another consumer object, and we'll take one more consumer object here. Okay, I'm going to show how the consumer chaining works. Okay, so here also I'm saying a name, but this time the thing is a little bit different. The message is different. Maybe uh, released but not a hit. Released but not a hit, or it is flop. Huh? Hit or flop, like that, some message. Okay, the different message. This time what I'm going to do is, in 3, what I'm going to do is here I'm going to say a different message here, storing information in the database. Okay, now how the consumer chaining works is, we create a consumer of the same demo class, and consumer chaining equals to c1 dot end then c2 dot and then c3. Okay, this is This is pretty much this is how we declare it. And then hold on 1 second, I need to check something. Okay guys, sorry for the interruption. Yeah, so let's declare a object here of demo, and let's give a name because it is accepting a name, right? So maybe spider. Okay, all right. Now we have to call this consumer object reference here, cc dot, and it always have an accept method for the accept method, and we have to pass this demo. Okay, we are passing this demo. That is what we are doing, right? We are passing this demo. Let's run it. What is it saying? Already exists. Let's rename it. Source. Let's see if we can rename it properly this time or not. Rename. Come on. Yeah, I have to click hit this one, and then demo A. We'll say demo A, and update. Yeah, let's do everything this time. See, yeah, we did it. Last time we were not able to do it, right? We did not check all the check options there. So yeah, we have updated our demo to demo A. Now it has a C with the single. This is consumer chaining. So we have called this consumer and this consumer, C1, C2, C3, and that's how we are going to implement it. Okay. The thing is, where are we going to implement? How are we going to implement in the project? It depends upon your requirement. So, but it's always good to know all the options before you land up in the project. So so when someone declares a consumer, if you don't know what the consumer is, why it is being defined, it will be very difficult for you on day-to-day basis to complete your task. So that's why it's always very important to understand all the new concepts. Now let's look into supplier. Now let's look into the supplier, how we can implement a supplier class. To be short, let's implement it right away here. So the main important thing about the supplier is the supplier. What it does is it just supplies a functionality, and it doesn't return any value, but its responsibility is just to supply things for your program. So the way you define is supplier, and say for example it's date. Okay, as equals to, you don't, new date, and system out. Yes. Okay, let's import this package. Even date package should be imported. Let's rerun this function. What is this? Wow, it is displaying the class, the object name here. We don't want this object name, right? Dot s dot local I think it's local date, local date, import local date. Let's see, and here also let's put local date. Add an argument. Oh, okay, local date and time. Let's see. Maybe it can supply a string based on the convert it into a string. I don't. Let's see. What is the problem with this? Okay, let's see. It was in this format, right? His date is outdated or what? Let's check. Okay. I am not quite sure, but I have done this kind of example somewhere else. So let's not get into this. We will come back to this later. Let's implement a separate class for supplier where we can give them the functionality. With the dates, I'm not pretty sure. Maybe this date I have to check how exactly we have to implement it. Instead, we can just create a supplier with small functionality, and then we can go from there. Okay, supplier. We are so supplier, when we hover on it, what it is saying is there is no requirement that new or a distinct result be returned each time the supplier is invoked. Okay, supplier. Okay. So, what we are going to do is it supplies only the functionality, right? So let's declare a reference for this. So what we are doing is we are returning a string output. Okay, string as an output. We are returning some value, string value. Okay, and what this function is doing is it is accepting, it is generating, maybe we'll generate some OTPs. Okay, we'll generate some OTPs, and the way we generate is we'll the OTPs, I think it's probably going to be 5 or 6. It's 6, I think, right? If I remember it properly, it is 6. Let's generate an OTP value here. That is what the supplier is going to do in our function. So we are going to assign it here to OTP plus there is a random number generation for in math package, math.random, and then we are going to, if we multiply with 10, it's gonna generate a number. Okay, it's gonna generate a number which and then we are just going to return this OTP. Okay, yeah, that's pretty much it. Okay, now let's print this OTP. S dot get. For supplier, it's always get. Just remember that. It should be in. Okay. So if we print it, oh my god, I think we have to convert it into a integer here, I think. Then it's going to be a short number. Yeah. So yes. Yeah. So if we so the suppliers, the responsibility of a supplier is just to supply the functionality which it has. That's it. So if you see, none of these OTP numbers are duplicate. All the numbers are unique. There is no repetition. That is what a supplier is going to do. It's just gonna give you the functionality, and it's going to return provide you the utility. So we have so far we have looked on predicate, which calls a test method, and a function which calls apply method, and a consumer which calls an accept method, and a supplier which calls a get method. Okay, and the same thing, guys, you have these are the methods, right? Predicate, you have test method to call. Function, you have supply method. And consumer too, you have accept method, and then supplier with the get method. The same thing, you have different interfaces, like by predicate. Okay, and that will accept two variables, input variables, and it returns a boolean. Always predicate means it always returns a boolean. This will always returns a boolean, and here it will return, where is it? Okay, let me erase this. Okay, it is arising very little area. It's very slow. All right. So yeah. So as we have seen just now, supplier will call get method, and it will return. It can return. It has a return type. It has a return type. This has a boolean return type. Boolean. And function can have a return type. If it is a bi-functional thing, it means bi means two. It will accept two variables, and it can return any in output. And then consumer just consumes the thing, but it will always return void. Okay, and supplier, we just saw that it just supplies the utilities, and it will give the return type as well. So we have predicate also. By predicate, we have by predicate which can take two integer inputs. It can take not only the integer variables, but also it can take objects as well. So if you look into the libraries here, if you look into the libraries here, where are our libraries? Yeah, it is right here. If you look into the library here, by predicate, yes, by predicate, it's taking any variable, any object. It can be anything. So it represents a predicate Boolean value function of two arguments. Okay, it represents a predicate Boolean value, but it returns a Boolean value, and it takes two variables arguments as a input, and it returns a Boolean type. And bifunctional, you can even have a look at bifunctional. This is also the same thing. It takes two argument and produces a result, and result can be depending on what you declare. If you declare a string, you have to return a string variable. If you return an integer, you have to return an integer variable. So based on your how the things are implemented, bifunctional. In the same way, you have by consumer. By consumer also the same thing. It consumes the data. Say for example, it's taking a integer employee object, but it is returning a double. Then you have to make sure you're updating the employee object salary or something like that. I hope, see, maybe we can do this example very quick, and then we can wrap this session. Let's do a last example on by consumer, and then we'll wrap it. So do we have an employee class here anywhere? Let's reuse the employee class for now. Yeah, we do have an employee class with the salary. Okay, that's a good thing. Let's get rid of all these things for now. Okay. Now what we can do is we will create an array list of employee class, employee 13, right? We have created employee 13 is the class name. So let's employee 13, and it is taking let's create a array list object here, and new array list employee 13. Okay, all right. And then let's populate the value. We can use a separate method here to populate. Let's not use any of these interfaces. Do we have an interface here? No, right? Okay. Then let's create a static method here, which implements creation of list of all the values of employees. Populate, which takes array list of employees, list of all employees, and let's populate this list. Dot add of a new employee, Siri, comma, and salary is 1000. Okay. 13. It should be 13, right? 1000, and one more thing, yeah, ID we have to provide, right, for here. Yes, and let's do it one more. John 5000. Okay, that is pretty much it. Why is it saying what is it saying? L dot. Okay, yeah, here also we have to say the same thing. Okay, all right, we have created a populate method which creates generates all the values for the list. Now what we have to do is we'll just call this populate method here and pass this L list here, and then we'll use by consumer. Okay, by consumer. What is by consumer? It is taking an employee 13 object and it is returning. Come on, come on, come on. It is returning a double. Okay, it is returning a double here. So here I'm gonna give object and the D and the lambda expression. Okay, E dot salary equals to E dot salary plus we'll add 500. Maybe we'll just add 500 for all the salaries. Okay, and then what going to do is we'll iterate through L, iterating through L, all the list. Again, let's create the employee reference here, and then we'll say C dot accept of E and 500. Yeah. So by consumer, okay. That accepts two input arguments, right? It's accepting two input arguments, employee and another type is double. So we are giving two input arguments. Here how can we add a D? Let's say D here, okay. Integer. Okay. Then okay. If not, you can just put a dot in. You can just put a decimal after 0, right? That will also is accepted. And then let's print it. And then let's print it. It's out of E dot name, employee name, and employee salary. That's it. That is pretty much it. Employee salary. Okay. Yeah. Did we not? We did not forget anything, right? Yeah. See, we have initially gave 1,000, but with this consumer, by consumer we have added 500 for all the employees, so that's why it is coming 1,500. That is pretty much it, guys. It is very easy, all the things. Please practice, do some examples, like instead of me doing some additions, you can do multiplications, square roots, all these things, and you can have hands-on experience. I hope you like this video. You can play with all different types of functional interfaces, lambda functions. Please like, share and subscribe. Thank you.